In this video, we will introduce another technique to differentiate a function, which is called implicit differentiation, right? So far, all our functions are given explicitly, right? For example, in the function in the form y equal to f of x. So this function here is defined. This is explicitly defined. Explicitly defined. Right? But there are many functions. X, Y contains in the same equation. They are both in the left side, right? Something look like this. So you have f of x, y equal to 0. Y here is also considered, y is also considered as a function of x, right? So as x change, y change. And now we still want to get dy over dx, and all the rules or definitions we have learned failed, right? So for sure, this implicit differentiation is used on differentiating implicit function, right? So we want to handle implicit function in the form of f of x, y equal to 0, right? We want to find dy over dx, right? So how do we do that? What do we do? Okay, let me write down the steps, right? Step 1 here is differentiate, just differentiate it, right? Differentiate both sides of the equation with respect to x, right? Consider x to be the independent variable, then differentiate about x, right? If you like have y in there, just write down dy over dx because that's something we are looking for, right? And step 2 here is after you differentiate both sides about x, you get a new equation. This new equation for sure contains dy over dx, and solve for that, right? Solve for dy over dx, right? Using some algebra, we can solve it. Let's see a example here, right? Let's see example. We are given an equation which is x cubed plus y cubed equal to 6xy, right? Always in this kind of equation, we consider this give a function form. I consider y here as a function of x. X is independent, y is dependent, right? So we are looking for find dy over dx, right? Consider x to be the independent verb, right? So let's follow our steps. Step 1 here is differentiate both sides about x, right? So what's the derivative of x cubed about x? Just a 3x squared, that's easy, right? Second term, y cubed, right? Y cubed, consider y as a function of x, but we don't know the function form. While y is still a function of x, so this is basically a composition of two functions. Y has an unclear form of x, and also outer function is to the power of 3, right? So when you try to differentiate the middle term here about x, you get 3y squared, right? Outer function is square to the power of 3, power function. You bring down 3, then subtract that. You need to multiply the duality of the inner function. Inner function is y. We don't know what's the function for, just keep dy over dx, or y prime, right? So the second term here, I mean, the term on the right side is the product of two functions, 6x and y. The duality of 6x is about x is 6, so you get 6 times y. For sure we want to use product rule, and plus 6x times the second factor is y. The duality of y about x, we don't know that, we'll just keep it. So dy over dx, right? That's it. So that's how do we differentiate both sides of our given equation about x, right? Then we just apply our step. We follow our step. Step 2 here is solve for the unknown. Solve for dy over dx, right? How do we solve for that? Moving all the terms contain dy over the dx to the one side. All the other term doesn't contain dy over dx to the other side, right? You get 3y squared dy over dx minus 6x dy over dx equal to 6y minus 3x squared, right? Take our common factor, which is our dy over dx, because this is our unknown. 3y squared minus 6x times that is 6y minus 3x squared. So we get our the derivative, right? Derivative is 6y minus 3x squared over 3y squared minus 6x. So this is how do we apply the implicit differentiation to get the derivative of a given function if the function is given in a implicit form.